All right, application window. Oh, we might have to do this first. Okay, yep. Okay, so as we get going here today, did anybody have questions from 4.3, the material that we've gone over thus far, that they wanted me to review? Okay. We weren't quite done with 4.3. There were a couple more things that I was going to go through. So I will continue on with them if that's all right. We graphed some transformations, we did some of the properties, but we haven't talked about finding the domain. All right, so if you're asked to find the domain of some function that is a log, what you have to remember is that for any log function, where you have log base a of some value a, that value a must be greater than or equal to 0. Well, sorry, not equal to. It must be greater than 0. That means that in this case of f of x, this x plus 5 must be greater than 0. And thus x has to be greater than a negative 5. In interval notation, this would be a negative 5 to infinity. We can kick that up a little bit in difficulty. Now, for this guy, it's important that you remember what the natural log is, that ln is the same as writing log base e of x minus x squared. So for g of x, it has to be true that x minus x squared is greater than 0. If I factor this, I get x times 1 minus x has to be greater than 0. We're going to go back now to week 3 and pull our skills from section 1.7. We know that x cannot be 0, and we know that x cannot be a 1, and that splits my number line into 3 sections. I'm going to try a number in each section, say a -1, maybe a 1/2, and over here like a 2. If I let x be a -1, that's going to be negative. Then 1 minus a -1 is positive. A negative number times a positive number will give me a negative result in this section. Meaning, in this section of my number line, it's not going to be greater than 0, it's going to be negative or less than 0. So I cannot use this section. If I let 1/2 be the representative of between 0 and 1, if I let x equal 1/2, I have a positive number, and 1 minus 1/2 would also be positive. When I multiply those two factors together, a positive times a positive, I'm going to get a positive result, meaning testing from this section of the number line gives me solutions that are all greater than 0. So this section of the number line will work. Then I'll check a 2 on the far side of my number line. That's going to be positive, but 1 minus 2 is negative. When I multiply a positive factor by a negative factor, I will get a negative solution, meaning it won't be greater than 0, it will be less than 0. So this section of the number line will not work. Thus, my domain in interval notation would be from 0 to 1. Questions? Hi. Shayna, you all right with that? Thumbs up. Thumbs up. Okay. All right. The only other thing in 4.3 that I didn't get to were some of the application problems. From your textbook, number 98 is a good example of what you're going to have here. It basically is a word problem that says a certain strain of bacteria divides every 3 hours. The colony began with 50. the time t in hours required to grow to N bacteria is given by the formula. Three times log of N divided by 50 over log of 2. And then it asks you to find the time required for the colony to grow to 1 million bacteria. All right, so these are pretty great in that basically for 4.3 at least, there's not a lot you can do but plug and chug the numbers in. For 4.3, you have not done a whole lot of work with the different properties or laws of logarithms. So most of what they're going to do in the applications here are give you some sort of long-winded application with a formula, and you just have to figure out where to put the numbers. In this case, they've given us 1 million, and this is going to be our n. They want us to find the value of t. So it's going to be 3 times the log of, and we're just going to plug in 1 million, divide that by 50, and divide that by log 2. So this will be log of 20,000 divided by log 2. So really, you're just practicing with the calculator, doing a log of 20,000 and dividing it by log of 2 to get the 14.2877 bunches of numbers, and then multiplying that by 3 to get about 42.9 hours. Questions on that guy? Okay. Those were the only 2 remaining parts of 4.3 that I wanted to go over. And so then with the remainder today, I was going to start in on 4.4. So let's start in. This is 4.4 and the laws of logarithms. Okay. So to start with, we're going to make sure that a is a positive number. And it can't be 1. So I'm going to use a lowercase a in my notation here, and it's going to be a positive number, but it cannot be 1. Then we're going to let a, b, and c be real numbers. We're going to let a be greater than 0, and b is going to be greater than 0, but c can be anything. Then there are 3 laws that we can apply. The first law says if you have a log base a of a product a times b, keeping in mind that both a and b have to be greater than 0, then it must be true that this is equal to log base a of a added to log base a of b. The second law says if you have log base a of the division of a and b, so a divided by b, this has to be equal to the log base a of a minus the log base a of b. The third law says if you have log base a of some number a taken to a power c, remember a had to be positive, but c could be anything. This is the same as pulling that value of c out front and multiplying it by the log base a of that value. Now, are these 3 laws, in particular, are the first 2 laws ringing any bells for you? With what? Do you remember, Austin? Sure. How is it ringing a bell? Do you know with what? Oh, okay. All right. This rule actually comes or is derived from what happens when you have, let's say, x to the third times x to the fifth. This is the same as x to the 3 plus 5, right? Where you're adding them. So when we're multiplying the bases, the exponents can be added. So when we're multiplying the results, that's the same expanded as if we've added them. Similarly, x to the 5th over x to the 3rd would be x to the 5 minus 3, which is x to the 2nd. So logarithms and exponentials have a sort of symbiotic, that's not quite the word I want, but they have an almost reflexive relationship. So a rule in the exponentials is reflected by a similar rule in your logs. So there's a connection here because your logarithms are a way of writing exponentials. So their rules have a sort of symbiotic relationship. Okay, let's try something. All right, using the laws of logs, no calculators. To evaluate. Okay, here we go. Log of 50 plus the log of 200. No. Nope, you're on something. But when I add the logs, what can I do with their results here? I have log of A plus log of B. That's the same as log of so 50 times 200. So that's going to be the log of 10,000. When the log doesn't have a base, what base is meant to be there? So this is log base 10 of 10,000. Can you rewrite 10,000 as a power of base 10? Ten thousand is 10 to the 4th power. Good. Now that I have log base 10 of 10 to the 4th, do you see how I have a to the c here? Just like this guy, a to the c. So now I can pull that 4 out front, and I have log base 10 of 10. This right here is just a fancy way of writing 1. Log base 10 of 10 is 1. So this is 4. All right. I wrote them all out, all of them steps. That's how we work it through. Okay, let's try another one. Log base 2 of 60 minus log base 2 of 15. Are the log bases the same? If they're not the same, these laws won't work. But because these bases are the same, I can equate this to the second law. So this should be the same as log base 2 of 60 over 15. Or log base 2 of 4. Sorry. Now, can you rewrite 4 as 2 to some power? 4 is good. And now I've got a squared here, which I can pull out front. 2 times log base 2 of 2. And log base 2 of 2 is just a fancy way of writing 1. So this guy is just 2. Oh, let's keep it going. I got 3 more of these guys. 1/4 log base 3 of 81. I'm going to keep the 1/4. I'm going to keep the log base 3. Now, can I rewrite 81 as 3 to some power? Can you do the factorization of 81? Correct. Now that I have this as a to some power c, I can pull that power out front. So that 4 times 1/4 times log base 3 of 3. Log base 3 of 3 is just a fancy way of writing 1. And here I have 4 times 1/4, which is also 1. Here I have log base 5 of the square root of 5. So can you rewrite the square root of 5 as 5 to some power? Thanks for remembering, Austin. The square root is a 1/2 power. In case you have forgotten that piece. So now I've got a power on that, so I can pull that out front. Log base 5 of 5. And again, log base 5 of 5 is just a fancy way of writing 1. So that's going to be 1/2. Let's try one more and see how it goes. We've got a log base 2 of 6 minus a log base 2 of 15 plus a log base 2 of 20. Are all of the bases the same? Base 2, base 2, base 2. So this would be a log base 2 of 6 minus 15 means that will translate into 6 divided by 15. And then we're going to add a 20. So this would be times 20. Six over 15 times 20 gives me an 8. Eight can be rewritten as 2 to the power of 3. That 3 is now an exponent that can be pulled up front. And log base 2 of 2 is 1. So this is just a 3. Questions? Okay, anyone else? Alrighty. Glad to hear it. Okay. So that's the first bit. Okay. Okay. So what we're doing in this grouping and in the next grouping is we're basically trying to hone your skills and practice them. So we're asking you to take something like log base 3 of 8x and manipulate it using the laws of the logarithms. So looking at this, you have the log base 3 of 8 times x. We're asking you to simplify this or to expand it by saying this could be the log base 3 of 8 added to the log base 3 of x. Now, can you rewrite 8 as any kind of power? Not with a base of 3, but any base. The prime factorization of 8 would get us log base 3 of 2 to the third. Now, because I have a log base 3 of 2 to a power, I can pull that power out front. To have 3 times log base 3 of 2 plus log base 3 of x. And this is my expanded notation. Likewise, if I have something like ln of a, to the third, we're asking you to see that that a to the third power can pull the 3 out front. And I can rewrite this as 3 times the natural log of a. Can't do anything more to it. That's it. Questions so far? Okay, let's see what we can do. Which one do I want to do? Let's try log base 5 of 3x squared over y cubed. Well, let's make it complicated. So where are we going to start with this? I would start with the division. Yep. I would start with log base 5 of the numerator minus log base 5 of the denominator. That would be my first step. Now, the numerator has multiplication in it, so I could split this up further. Log base 5 of 3 plus log base 5 of x squared minus log base 5 of y cubed. Now we would deal with those exponents. Log base 5 of 3 plus 2 log base 5 of x minus 3 log base 5 of y. One step at a time. Okay? Okay. So that's the expansion. And then we also combine. All right, let's try a couple of these guys. So we can do it with just numbers. The first example here is one that is only using the numbers. We have a log base 4 of 6 added to 2 times log base 4 of 7. And what we want to do is move some combinations around here. So the first thing I'm going to do is take this 2 that's out front and put it back on the exponent, back on as an exponent for 7. So I'm going to do log base 4 of 6 plus log base 4 of 7 squared. That's 49. Now, just like we did earlier, these are both log base 4. So if I have a log base 4 of A added to a log base 4 of B, that's the same as log base 4 of 6 times 49. This is going to be a log base 4 of 294. I'm going to divide that by 4. I don't think I'm going to get anything. Yeah, I'm not. This does not simplify as 4 to any power. So this is the best I can do with it. It's log base 4 of 294. And for right now, this is all I can do. That's its combination and simplified form. All right, let's try one with exponents and see what happens with variables. Okay, yeah, let's try this one. Here we've got a 3 ln 2 plus 2 ln x minus 1/2 ln x plus 4. And just like I did up here, I'm going to take any multipliers and put them in as exponents first. So 3 ln 2, I'm going to rewrite as ln 2 to the third, plus 2 ln x, I'm going to rewrite as ln x squared, minus 1/2 ln x plus 4, I'm going to rewrite as ln x plus 4 to the 1/2 power. This is going to be an ln 8 plus an ln x squared minus ln square root x plus 4. Now, These are all the same log, ln, 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 which is a log base e. Since they're all the same, ln a plus ln b is the same as ln 8x squared. Multiplying, subtraction is divided by square root of x plus 4. And I've combined them. All right. Questions on either of those? No, we're good. Okay. Okay. All right. So that's what I had for today. I don't have anything further to get through. So you guys are all good there.